So the next section we're going to go through, and that's going to be the last thing we do for today, is section 8.3, which is about perimeter and area. Okay. And so the perimeter, which is typically denoted with a P, is the sum of the lengths of the sides of a figure. So basically, if you walk around your house, add up all that distance you walk, that's your perimeter. So this is just going to be a single unit. It's going to be feet. It's going to be inches. It's just a measure of the distance. Area, on the other hand, which is denoted with A, is the measure of the region within the boundaries. Of a figure. So it's some flat image, you're kind of seeing how much of that surface it's taking up. So because of that, it's a two-dimensional thing. This is going to be your units squared. So area will be square inches, centimeters squared, any of those. So we have a ton of formulas. What I'm going to do is give you kind of a chart for it, where I will draw the shape. I will write a formula for the perimeter, and I will write a formula for the area as well. If you can kind of nail these two-dimensional shapes, it's going to make our next section much easier, which is where we add a third dimension and talk about volume. So you really want to know these down pat, especially the area. Perimeter is just adding up the sides, so hopefully that won't be too bad. So let's start with our triangle. To know everything about our triangle, which is here, you need a couple things. You have sides A, B, and C. Your perimeter then is just the sum of these. Add up those three sides. The area, on the other hand, needs something different. And so what you need is a straight line that drops down to one of the other sides. And this gives you a height. So I'm going to reorder where these are just to make our formula match what's in the book. I'll call this side C, this side B. You need this length and the side it runs perpendicular to be able to find the area of a triangle. And so this area is 1/2 that base times the height. So you need the side that the height hits to find that area. If I move on to a rectangle, this will be some length, some width, and these will be the same, length and width. And remember, all of these angles are going to be 90 degrees. If I want my perimeter, I go ahead and add up WWLL. So ultimately you have 2 times the length plus 2 times the width. And the area of our rectangle is just length times width. If we look at a square, it's just a special case of our rectangle where all of these are the same side length. So we call it S. All our angles are still 90 degrees in here. If I walk around this figure, the perimeter is 4 times that side length. And the area is side times side, so the area is going to be the side squared. Next up, we've got our trapezoid. So I've got those 2 sides that run parallel to each other. And then these ones just kind of connect the dots. The two sides that run parallel are definitely the most important. So that's called V1 and V2. So these are the parallel figures. These ones we'll just call side 1, side 2. So this is not something you need to memorize for the perimeter. Really, the perimeter formulas you don't need to memorize. You just add up the edges. But you just go ahead and add all of these side lengths together. For our area, this one's a little more complicated. So I need to know the distance connecting those two bases. So basically, again, this is called the height of our figure. To find my area, it's kind of like the triangle, 1/2 base times height. But the problem is because you have those two bases, you do base 1 plus base 2. So it's kind of like you're finding the average of the bases. So base 1 plus base 2 divided by 2 is the average length of those bases, and then times the height. All right, and then finally, let's see if I can move some of this stuff a little bit. Move that up so I can fit in our circle. So that is our last 2D shape, beautiful. Circle is the one that's completely in left field. It's got some center. It's got a distance from the center to the outer edge, and it's called R. So this R is called the radius. Okay? That is all you need to know about a circle to be able to find all of the important things. If I go ahead and I look at the distance from edge to edge through that center, this total distance is 2R, and that's called our diameter. So 2R is labeled with a D, it is the diameter. So when I talk about perimeter, we don't really call it perimeter. It's instead labeled with a C, it's the circumference. Okay. But basically, it's like the perimeter. It tells you if you walk around the circle, how far you'd end up walking. So that circumference is 2 pi times the radius, but 2 pi is just the diameter. So it's really the diameter times the number pi, just like 3.14. So that's why I'm leaving it in the perimeter section. The area, different. It is pi times the radius squared. So let's try a ton of examples working with these formulas. We want to determine the area and perimeter of the shape. And so the first one we're going to do is a parallelogram. Again, definitely not drawn to scale. This is 27 centimeters. This is 3 meters. And we are told this distance between those two sides is 20 centimeters. Okay. Big thing you have to be careful about, these aren't the same units. So I can't just jump into using my formulas. Instead, we need to convert to centimeters. Okay. So going through some refresher, we've got King Henry died by drinking chocolate milk. And then we go ahead and we're dealing with meters. So put an M next to everything. We are starting here at meters and we want to go to centimeters. So I have to move my decimal 2 places to the right. So moving that 2 to the right gives you 1, 2. This bottom side is 300 centimeters. Okay. So really the figure we're working with, move over here. This bottom side is 300 centimeters. I'm filling in the pieces. This is a parallelogram, so this one's 300 centimeters, and this is 27 centimeters. So for our perimeter, that one's not so bad. We go ahead and add up all those side lengths. It's 300 plus 27 plus 300 plus 27. In total, you have 654 centimeters that you would walk if you walked around the surface. And then our area, you can use the trapezoid formula if you want, because technically it's a trapezoid, but since it is a parallelogram, it's just the base times the height. So that's going to be 300 centimeters times 600 centimeters, or sorry, 20 centimeters, which gives you 600, and your units are centimeters squared. So you don't really need to write these at the time. If you'd like to indicate those units, go ahead. But area, square, perimeter is just flat unit. Okay. Let's try a circle now. So here is our center, and we are told this total distance from here to here is 13 millimeters. Well, that's not really helpful for me because if I want to know my area, I need to know my radius. So my radius is going to be this total distance divided by 2. So my radius is 6.5 millimeters. So this is 6.5, this is 6.5. My perimeter is my circumference. It's 2 pi times my radius. So that's 2 pi times my radius of 6.5, which if you do that, 13 pi millimeters is the exact circumference. If you plug this into a calculator, it's about 43.98 millimeters. So I'll go ahead, pull up my calculator. There we go. You have a pi button, don't need an add. Right here, I want to do 13 times pi, so I can do 13 pi. It equals, and it's about 40 point, yeah, so it's about 40.84. If you do 3.14 for pi, that works the same too. So let me, correct this a little bit. It should be about 40.84. So be careful on your phone and in your button. So if you use 3.14 for pi, you're also going to get something slightly different. All right, if we want to do the area, it is pi times your radius squared. So that is pi times our radius, which is 6.5 squared. And so that's definitely not a nice number. Let's go to a calculator. We want to do 6.5 squared. And then we want to times that by pi. And our area is about 132.73. Well, keep going to that. Don't mind, 132.73 millimeters squared. Okay. Boyfriend was making a Rocket League shirt, so he needed a logo. All right, so we're going to keep working. We're going to step it up a little notch now. And we're going to determine the area of the shaded region. So I hope perimeter is not too bad for you. That's why I'm not really doing a ton of those. We haven't done all of the shapes yet, so we're going to get some more practice with them now. We're going to have this funky shape. Well, that's not the shape I drew at all. Let's see. Nope, it just wants to change it into a rectangle, and I don't want a rectangle. Okay, let's do this. All right, there we go. That's a good shape. Then I'm going to go ahead and draw a triangle within here. And then the area we want to find, let's color it in yellow, is going to be this shaded region and this one here. We've got lots of information that we're told. Let's see. This distance, if I go straight down here, is going to be 10. Hold on. Okay, so we're told that side is 10 yards. And then we are told this side is 11 yards. This side is 9 yards. And this total side down here is 18 yards. Okay. So I've got a problem because I have two funky shapes that I clearly do not know the heights of these triangles. So I've got to do something a little bit different. If I want to find the area of the shaded region, left out two things, these are 90-degree angles. I need to go ahead and take the area of this larger figure and take out the area of this triangle in the middle. That larger figure is going to be a trapezoid. Explain in a second. And then we're going to delete the area of a triangle. Okay. So because these two angles are both 90 degrees, these sides have to run parallel to each other. Okay. So those are kind of like our bases. This is base 1, this is base 2. The distance between them is exactly this 18. So that is our height. Okay. So I'm going to go ahead and find each piece individually. Let's start with the area of the trapezoid. So that's going to be 1/2 the height times base 1 plus base 2. So our height in this case is 18. Base 1 is 9. Base 2 is 11. So kind of going through each of these, if you do 1/2 times 18, that's going to be 9. 9 plus 11 is 20. Area of this trapezoid is 180. And our units are going to be yards squared, since it's yards. I move on to the triangle. That's going to be 1/2 our base times height. And so in this case, our base is that 18 and the height is 10. 1/2 times 18 again is 9 times 10. So this is 90, same units, yards squared. So now I'm finally at a point then I can find the area of the shaded region. And that's the area of the trapezoid minus the area of the triangle. Our trapezoid is 180 yards squared. Our triangle is 90. So subtracting those two, the area of the shaded region also is 90. Okay. So you're going to have to get creative for sure with these, but it's the same kind of general idea that you're going to do area of the larger minus the area of the inner. So let's try one more for our shaded region. Again, definitely not drawn to scale. Your book will do a much nicer job. Okay. And the area we want to find is all of these little pieces out here. And we are told these are all 90 degrees. We are told the distance from corner to corner here through the very center is 10 meters. This side is 8 meters, and this side is 6 meters. So again, the area of our shaded region, my larger shape is the circle, so I'll find that area. And then I want to remove the rectangle in the middle. Okay. So starting with our circle, it is pi times the radius squared. Problem is, I know this total distance. So our radius is half of that. The radius is 5 meters. So this is pi times the radius squared, which exactly would be 25 pi, but can't really use that. So let's go ahead and go back to a calculator. We want to do 25 times pi. It's about 78.54. And our units are meters squared. Moving on to our rectangle, it's just length times width. So that is 8 times 6, or 48 meters squared. So we go ahead and find the area of our shaded region by subtracting the two. It's 78.54 meters squared minus 48 meters squared. Roughly this area is 30.54 meters squared. Okay. So just pay attention when I ask you to round what you have to do. Be careful with plugging things into your calculator as well. We're going to go more in detail again because we're going to add a third dimension to this in the next class. So we're still going to be using these areas and shapes over and over and over again. So really the last thing I have to do now is talk about something that's special for right triangles, which can help us determine perimeter and area as well. And that is, don't mind my dog in the background, she's trying to get a toy. It is the Pythagorean Theorem. Macy, no. So basically, this works only for right triangles. You've got a right triangle here. Make it look really obscure. This is called one leg of the triangle. This is called one leg. They form that 90 degrees. The side across from it is called the hypotenuse. So in a right triangle, if you take one leg squared plus the other leg squared, it's going to equal the hypotenuse squared. Or in much nicer terms, if I call this A, B, and the long side C, A squared plus B squared equals C squared. Okay. So something super, super special just for right triangles. Okay. So I've got one final example. We're going to find the perimeter and area of the triangle. Okay. So the triangle we're given, oh, sorry. This one here is our right angle here. This is 8 and 10 inches. I have zero idea what this side is, so I'm going to call it A. Okay. So if I go ahead and use my Pythagorean theorem, A squared plus 8 squared should equal that long side squared, which is 10. So that's A squared. 8 times 8 is 64. 10 times 10 is 100. Then we go ahead and subtract 64 to give us A squared is 36. And so you're looking for a number times itself that gives you 36. Or if you remember from before, it's the square root of 36, which is 6. So this remaining side is 6 inches. Okay. And so immediately now I can go ahead and find our perimeter. We add these side lengths together, 6 plus 8 plus 10, to give us a total of 24 inches that we would walk around. And our area is 1/2 the base times the height, which is going to be those two sides that form that right angle. So it's 1/2 times 6 times 8. 1/2 times 6 is 3 times 8. That is 24. And the units will be inches squared.